Hello student, we are today going to learn about Kepler's law of planetary motion. See, Kepler's first law, what it was? See, he stated that all planets revolve around sun in a elliptical path with sun at its one of its foci. What is that? Every planet revolve around sun in an elliptical path with sun at its one of its foci. See, we have learned in conic section that ellipse is what? X square by a square plus y square by b square, and it has two focus, and among these two focus, one focus lies the sun, and planet moves around this. This is the elliptical path. Now we'll move on to our second law. What is that? Kepler's second law. What is that? That is law of area. Law of area. See over here it states that, see, let us suppose this is the sun and the planet moves around in an elliptical path. So this law states that this is P1, P2, this is S1, S2. See, it states that line joining planet to sun carves out equal area in equal interval of time. That is what? Area of the curve as S1, that is as P1, P2 is equivalent to area of as S1, S2. That means this length is what? Comparatively less. P1, P2 is less than S1, S2, and they have covered in the same time. This means velocity at P1, P2 is less than velocity at S1, S2, because it has to move fast, and we can even prove it out. How come? See, we know that angular momentum can be written as what? L is equal to twice m into delta A by delta t. And we know from the law of conservation of angular momentum that if no external torque acting on the system, total momentum of system remain conserved. So torque is what? Torque is delta L by delta t. So what we have? This is twice m into delta A by delta t. So when torque is 0, so twice m into delta A by delta t is going to be constant. So we already know the mass is going to be constant. So delta A by delta t is also constant. So it is proved that the law of area, that line joining planet to sun carves out equal area in equal interval of time. And third is law of period. What is that? Kepler's third law. What is that? This is law of periods. See, it states that T square is directly proportional to R cube. Means the square of time period of revolution of planet around sun is directly proportional to cube of distance between planet and sun. See, we can prove that out. How come? See, it says that Centripetal, we know that centripetal force is equal to gravitational force. Centripetal force is what? mg square by r. This is what? gmm upon r square. See, we know that relation v is what? V is equivalent to omega r, and we know that omega is what? It is equal to 2 pi by t. So this can be written as, we can have, this is mr, this is what? 4 pi square r square upon t square into r. This is gmm upon r square. See what we have? This and this get cancelled out. This get multiplied by it and becomes r cube, and this becomes equal to t square. So we are able to prove that t square is directly proportional to the r cube. That's all for now. We'll meet in the next class. Thank you.